Welcome to DTH channel. In today's session, we will discuss about ports and circuits of 8051. In 8051, we have 4 ports which are named as port 0, port 1, port 2 and port 3. Each port having 8 separate signals. Okay. The 8 signals totally 32 signals which are used for the input and output applications. Due to reducing the pin numbers during the fabrication, some signals are multiplexed with the IO signals. So, now we will discuss how each port signals will be multiplexed and how we are using each pins. In port 0, we have 8 signals which denoted with P0 0 to P0 7. The 8 signals are denoted with P0 0 to P0 7, which are used for the input lines, then output, then address line and data lines. Because here AD0 to AD7 signals are multiplexed. So, this port 0 is used for the port purposes. It will be used as input lines, output lines, address lines and also for the data lines. Port 1, which have denoted with port 1.0 to port 1.7, totally 8 signals used for the input and output. So, either you can use 8 signals as a input or 8 signals as a output. The next one, port 2, which denoted with port 0 to port 7. These 8 signals will be used as either input signal or output signal and also the higher order address lines, which are A8 to A15. Right. So, these signals are connected with here address lines, then here AD0 to AD7. The last port, which is port 3, the port 3 signal is denoted with P3.0 to P3.7. So, 8 signals. So, here these 8 signals can be used as input signal and also with the output signal. Along with that, the port 3 is supporting for the serial communication by activating the TXT RXT signal. Then 2 timers we have T0 T1 and 2 interrupts INT 0 and INT 1 and also the 2 control signals which are read bar and write bar. So, these 8 signals are used in the port 3. That is why the port 3 also call it as a multifunction port. Okay. So, these are the functions are built in with the each ports. Now, we will discuss each port circuits and how it will operate. This is a port 0 circuit. This kind of circuits will be used for the port 0 to port 0.7. So, for 8 lines having the same circuit. Okay. So, here one of the D latch is connected along with the control circuits with 2 NMOS. Okay. Then 2 latches which are read pins are available. One is connected from the pin, another one from the latch. So, this is connected from the latch, this is from the pin. So, the read operations either from the externally you can read it when any one of the switch is connected. If you are pressing, then the corresponding one signal will be passed. Otherwise, already stored informations if you want to read from the latch, you can read it from here. Okay. So, for that we have a 2 read pin, then write latch is enabled. Okay. This is a address or data lines, this one is the control signal. So, within this control logic we have a mux, either it will select this signal or this signal. So, that corresponding signal only passed here. Okay. So, initially we are considering the control signal is 0. Okay. So, this is a general structure of port 0, right. Now, we will discuss how to read the operation in this port 0. So, this is a control signal, this is the address and data signal, right. Now, I want to read the data from the external pin. Suppose I pressed the switch. When the switch is pressed means I will get the value of 1 here. The 1 should be come to the internal data bus. So, for that I want to make the data pin as 1. Okay. So, now latch pin is 0, data pin is 1, at the same time the control signal is 0. When the control signal is 0 means this signal will be 0. So, this NMOS goes to off state. So, NMOS goes to off state means here there is no signal, at the same time the latch also, that is the right enable signal is always 1 to activate the clock signal, right. Okay. So, at the time this lower NMOS also 0 because of the lower signal, 0 signal already available in the Q bar signal is 0. So, both NMOS transistors are in the off state. So, now this signal in the floating state. So, now whatever you are given in the output pin, that will be passed via this path. So, the available signal, because of this read pin is 1. So, we are getting the short circuit. So, this signal will be come over here either to store or you can pass the internal bus. This is a one way we are reading the data from the pin. Suppose if you want to read the data from the latch, if already I have the data as 0, then this pin is connected. So, the short circuit will occur, right. So, during this time whatever you are giving, that available signal will be passed to the internal bus. Okay. So, the read operations will be performed from the pin or from the latch. From the latch means the stored data you can read it, from the pin means externally we are getting. Okay. This is a read operation in port 0. In port 0, how we are writing the data? Writing the data means we are sending the data from bus to the pin, external pin, this direction we are sending the data. So, this is a address and data signal, right, this is a control signal. Now, the control signal is 0. So, this transistor is going to off. Okay. Now, you are planning to write, at the time the read pin both are in the 0 state. Now, you are writing the value 1. If you are writing 1 means what will happen? D value is 1, D bar is 0. Because of 0, this control signal will be select, this mux will select only this signal. So, this will be disabled, that is this value is 0 means the lower mass also off. When this is off means completely it goes to ground. So, that time we are expecting this to be the pull up register. If you are using the pull up resistor, right, then here you will get the value of 1, plus 5 volts you will get it. So, if you want to write the value 1, you will get the value as 1. Suppose if you want to write the value as 0, then you write the value 0 here. Okay. So, now you get the value of 0, here Q bar is 1, because in the flip flop it will generate Q and Q bar both signals. Because of 1, this transistor will on. Once the transistor is on means what it will do, whatever the available value will be comes to the ground. So, because of this now the value is 0 here. Okay. So, this is a write operation from the pin, from the bus you want to send the signal to the external. Either you can want to write the value of 0 or 1, it will simply pass as a signal 0 or 1 with the help of the control signal. This is the address signal. So, here address and data signals we are using, right, this is a control signal. So, when the control signal is 1 for this, for read and write operation the control signal is 0, for address and data the control signal is 1. So, control signal is 1 means here you can consider this a mux. So, this value is I naught, this as I 1. Okay. So, based on this signal, normally how we are selecting two signals we are using for the mux 2 cross 1, I naught, I 1. So, only one output will comes, right, based on the signal. If it is 0 means you will get the I naught signal, if it is 1 means you will get the I 1 signal. So, in the previous case the signal is 0, so you will get only the I naught signal. Now, I am giving the 1. So, whatever you are giving that I 1, that will becomes, right, already based on the C the value is 1. So, this transistor is on, you will get the 5 volts. So, if you are whatever you are giving the value that will becomes, if you are giving the 1 you will get the value of 1, if you are giving the 0 then you will get the value of 0. So, this is a way we are passing the address Okay. So, in port 0 we have performed the write operation, read operation, right. During the read operation from the external pin we are reading, the write operation is we are sending the data to the pin and we can generate the address lines also. In port 1 is a simple IO ports, whether the 8 signals or 8 pins will be used as either input or output. By using this configuration we can send our own data to the external device. So, here internally the VCC is connected with the pull up resistor. So, here always having the 5 volts, or you can say the logic 1. Now, you can consider this as a read operation. Suppose you want to read the data, means the latch, okay. The both read latch should be disable, pin should be active. So, pin is active means you will get the short circuit. So, whatever the pin is available, this pin signal will be comes. During that time these two are floating. So, there is no signal will be passed. So, from the external pin you can read the data and it passed to the internal bus. If you want you can store it into the latch also. If you want to access the data from the latch, okay, this pin will be short circuited, this will be short circuited, the available stored data you can read it or you can pass it here. Okay. So, this way we are reading the data. Suppose if you want to write the data means internally you are assigning the data in the internal bus. Suppose I am giving the value 1, I want to write the data. The D latch what it will do, whatever you are assigning that will be comes as the output. So, here 1 is comes, because of the flip flop it will give the complement of its output. So, 0 you will get it. Because of 0 what will happen, this NMOS is on when you are applying the value is 1. When you are giving the 1, the NMOS will be on. When you are giving 0, the NMOS goes to off state. So, based on that principle, now you are giving the 0. So, this NMOS is off. So, off means there is no connection between this line. So, it become open circuit. So, whatever you are assigning in the VCC, that will be comes as output. So, the VCC value will be generated as a 1. So, you will get the external pin as 1. The same configuration or same circuit will be repeated for P1.0 to P1.7. So, 8 circuits will be used to get the required values. Suppose if you want to write the value of 0 means you are giving 0, right. So, the Q value will be 0, then Q bar become 1. If Q bar is 1 means what will happen, this transistor will come to the conducting state. So, conducting state means it form the ground. So, ground means whatever already stored values that will be comes to the ground. So, due to discharge now the value becomes 0. So, you consider when you are giving 0 you will get it as a 0, when you are giving the value 1 you will get it as a value 1. So, this is the way we are writing the data in the bus or whatever the data lines will be passed to the port signals. Now, we will discuss about the port 2. Port 2 which is having a 8 signals which are bidirectional signals, which is used for the 8 input lines or 8 output lines or 8 higher order address lines which are A to A15. Okay. So, now we will discuss how it will be used as a input, how it will be used as a output and also for how it generate in a higher order address lines. In case of input means what we are doing, we are getting the input from the external device or you can say we are reading the data from the external pin. Okay. You assume that 8 switches are connected. So, now you are on 4 switches and off 4 switches. So, what you will get the value 0f. Okay. So, the first 4 bits will get it the value as 1, the least 4 bits will get it as a 0. So, this way only we are getting, this is a read operation. Now, you consider the same port 2 how the read operation will be performed. Okay. So, now I have a pin here the value was 1, this 1 to be comes here. So, how it will comes? The control signal initially 0, initially 0 means this will be 0 and this also based on the Q bar signal is 0, here it is 0. So, both are comes to the floating state. So, this signal what you have given will be passed to here. Okay. So, the port 2 signals is given at that time the pin signal is 1, the latch signal is 0. So, because of that it will be short circuited. So, your signal 1 comes to here. If you want to store, you can store it or you can access it. Okay. So, this is the way we are accessing the data, external data. If it is 1, it will comes as 1, or if you are pressing the value 0, that also comes as a 0. This is a read operation. Okay. This is the read operation from the external pin. The same thing you can read it from the latch. Latch means already stored data, you can read it. So, for that this read latch pin is 1. So, automatically it make the short circuit. So, the available data, if it is 0 means that will be comes as output. Okay. So, this is a read operation, either from the latch you can read or from the external pin you can read it. Now, we will discuss how the write operation is performed in the port 2. So, for write operation the control signal is 0. So, control signal is 0 means the upper one is already connected with the pull up. So, you can consider as a 1. So, based on the 0 it will select the I naught signal. I naught signal is selected. So, whatever you are giving, based on that it will give the signal. Write operation means from bus to the external pin. So, this direction. Okay. Now, I am giving the value 1. So, 1 means because of the delatch it simply pass it as the output. Okay. And also the Q bar value is 0, because it is a characteristics of the flip flop 1 and 0. So, if you are giving 0, here I naught is selected. So, simply passed the I naught to the NMOS. So, this NMOS what will happen? It goes to off state. Once it off means only the VCC value will becomes. So, it will get the value of 1. So, you are writing the value 1 and also you are getting the value as 1. The same case if you are generating the value 0, right. If you want to write the value 0 into the pin P2.3. Okay. So, now I am applying the value 0 in the internal bus. Because of the delatch, the Q value is 0, the Q bar value is 1. The I naught only connected because the control signal is 0. If 1 is given, then what will happen? The short circuit is occurred. Short circuit is occurred means whatever the initial values that are also grounded. So, now this value is 0. So, either 1 or 0 you can send. Okay. So, send means it is a write operation. Write operation means from the controller to the pin we are passing the signal. So, the write operation means from the data line to the external pin we are sending the signals, which is sending the signals means writing operation from the data line to the any one of the pin, or you can consider the data signals which are connected with the LEDs, right. If you are giving the value 1 means the LED will on, if you are giving the value 0 means the LED will off. So, by that way here in this pin you connect the one of the LED, then you will get clear understanding what kind of signal you are passing. In the port 2, now we will discuss how the address will be accessed. For accessing the address, already we have discussed this is I1, this is the I naught signal, right. So, address is connected to the I1 signal. So, now I am giving the control signal as 1. So, you consider this is a mux, 2 signals I naught and I1, one output, right. Either it will be connected with the I naught or it will be connected with the I1. So, which I naught or I1 is selected based on this selection line. This is a 2 cross 1 mux. So, based on that concept here they have selected the controls logic. So, now 1 is given, right, automatically the I1 will be comes as a output. In that case this signal is always connected with the pull up high signal, right, 1. So, here whatever you are giving the value, based on that you get the address line as 1 or 0. So, whatever you are assigning the same signals will be comes as here. This is a way we are accessing the address lines. So, in port 2 you can use either 8 address lines or 8 input lines or 8 output lines. The next we will discuss about the port 3. The port 3 also name it as a multifunction port, because it will support the multifunctions which are for serial communication, right, with the help of RxD and TXD. Then for interrupt we have 2 signals INT 0 and INT 1. For timer we have a two 16-bit register T0 and T1, then two control signals which are read bar and write bar. So, these signals along with the input and output operations. Okay. So, now we will discuss how this pin will be used for the input operation. So, for the input operation, what it represents, whatever I am writing the signal here, that should be comes over the pin, right. Suppose I am taken the value of 0 here, I am expecting 0 on here, we will check it whether the path allowing the 0 to the pin. So, because of the delatch, whatever you are giving, that will be comes as here, right. So, now 0 is given. In the NAND gate, what is the principle of NAND gate, right. So, A, B, two inputs you have, both are 0, then the output is 1, then 1 0 1, 0 1 1, both are 1, then you get the value of 0. So, now you can get, if any one of the input is 0, then the output is 1. If it is output is 1 means what will happen? This transistor, because of NMOS, the transistor goes to on condition. Once the NMOS is on means which is in the pull down transistor. So, automatically it will drain the existing voltages, now the output is 0, right. So, whatever you are sending the value, that will be comes as output. Suppose here you assumed one of the LED is connected, right, in the port 3.0. If I am giving 0, the LED goes to off state, right. If suppose I am giving the value 1, if I am giving the value 1 on here, okay, delatch will pass the signal as 1. In this 1, if any one of the input is 1, we cannot define the output. So, that time I am getting the alternate output. Here the alternate output is 0. The same way you can use the signal to pass either 0 or 1. Okay. If you are passing 0 to write on the LED, it will goes to the 0 which is off. Suppose if you are giving the value 1, then the D flip flop is 1, the NAND gate become 0. Now, the existing value which is a pull up value become 1. If it is 1 means you will get the transistor is on condition. Okay. So, if you are giving 0, the transistor goes to off, if you are giving 1, the transistor is on. This is a write operation. Write operation means which is the output. So, whatever you have, you are sending the signal to the external device like a LED or any sensors or anything, you can get it. Now, suppose if you want to read the data from the external device, okay. External device means this is the way we are reading the data, this direction we are reading the data, right. So, during that time the pin signal will be enabled. So, you get the short circuit and we are reading the data. Suppose if you want to get the alternate pin means either via this you will get or this pin. So, among this few signals are input, few signals are output. So, based on that we are getting. In today's session we have discussed about the 4 ports. So, 4 ports which each having the 8 signals. So, totally 32 signals, each circuit will be repeatedly. So, 32 different circuits are used. How to activate the signals will be either input or output or based on the corresponding ports functions. In case of port 0, it will be used as input, output, address and data lines, right. In case of port 1, it is simple IO mode, either 8 input lines or 8 output lines. In case of port 2, it will be used as 8 input line, 8 output line and 8 address lines. Okay. The last one port 3 which have a 8 input lines, 8 output lines along with the multifunctions which are represents for serial communications, interrupts, timer and also for the normal control signal which are read and write. Okay. So, with this I will wind the session. Thank you.